wanted to do a few extra examples to make sure you feel prepared for all the questions on Exit Ticket 10.1. As you might have noticed, we started probability and statistics. Well, right now it's just probability. I'm excited for that because all the problems end up being application problems, so that is an upside. And perhaps a downside is that sometimes that means probability can be challenging when every single problem is an application problem. So two types of problems that show up in the exit ticket that I'm not sure the Khan Academy video sufficiently covered would be like probability from a chart, which I'm going to show you here, and then there are some questions that mention with replacement and without replacement when you're drawing marbles from a bag. And I just want you to be aware of how those two things work differently. So, from a chart, we have this example. It's a pie chart, and it shows a survey of 2,392 adults ages 18 and over asked what type of food they would be most likely to choose at a restaurant. The results are shown in the figure, and then it asks us, what is the probability that an adult chosen at random prefers Italian food? So you might have seen this notation used in the video. All it means is, if you see the P out here, probability of, and then what's written inside parentheses is kind of the event that would happen. So what's the probability of the chosen adult preferring Italian food? For theoretical probability like this, we're always thinking of number of outcomes that fit the condition over the total number of outcomes. So in other words, how many outcomes are there where the person chosen prefers Italian, and then how many outcomes are there in total? Those are the two things that get plugged in. Well, how many different ways could we choose someone that prefers Italian? Well, there are 526 people that prefer Italian, so there are 526 ways that we could pick someone who prefers Italian. We could pick any of those 526 people. Then, how about the total number of outcomes? Well, we could pick any of the people in this survey. And how many people are there total? Well, it doesn't tell us that, or it does tell us that directly. I have it added up in my problem. I guess that is unnecessary. It says it's a survey of 2,392 adults. So that's what goes on the bottom, because we could have picked any of those number of adults. And so number that prefer Italian food over number total is about 0.22. So you could write it as a decimal, or you could write it as a percent. You could multiply the decimal by 100 to get the percent, so 22%. So there's like one pie chart type problem on the exit ticket. Now, with and without replacement. So this will most often come up with like picking marbles out of a bag, but there might be other scenarios where they use this language. So the situation, suppose we have a bag containing 2 green marbles, 1 yellow marble, and 1 purple marble. It says, what is the sample space if you draw 2 marbles with replacement? How many outcomes are in the sample space? So first, remember, sample space is the set of all possible outcomes. So what are all the outcomes that could happen? And with replacement just means that when we pick a marble, afterward we put it back in before we pick the next marble. So for instance, if you picked, I numbered the green marbles because there are 2 of them, green 1, green 2. If you picked green 1 on your first pick, or the first time you drew a marble, you would put it back in and it would still be possible for you to draw it again. So that's why this outcome is possible. You could draw the green, you could draw the first green marble once, put it back in, and then you could draw it again. And so I list out all the possibilities here. So first I just list out all the possibilities where the first draw is green 1. And then there are 4 ways this could happen, mainly because there are 4 marbles. So if on the first attempt it's green 1, on the second attempt it could be green 1, green 2, yellow, or purple. Next I list all the outcomes where the first draw is green 2. Here I list all the outcomes where the first draw is the yellow marble, and here I list all the possibilities where the first draw is the purple marble. You might be noticing something that in order to find the total number of outcomes, we end up just multiplying the number of marbles by itself. 4 times 4, 16 outcomes. And that matches up if you count out all these outcomes. How does this change if we draw marbles without replacement? So you draw one and then you don't put it back in before you get the next one. And again, we're also wondering how many outcomes are in the sample space. So I copied the same outcomes over, and then I just wanted to think about which of these outcomes could not happen without replacement. And mainly, if you draw the green one the first draw, or the green 1 on the first draw, you could not draw green 1 again on the second draw because it would have been taken out. If your first draw was green 2, your second draw could not have been green 2 because that one was taken out and not replaced. Similarly, if your first draw was yellow, your second draw could not be yellow. If your first draw was purple, your second draw could not be purple. So those ones go away, but all these other ones are fine. And so you can see then that our list is reduced down to 12 outcomes. If you wanted to do this in a shorter way, 4 times 3 gives you 12. Why 4 times 3? Because the first time you're picking from 4 marbles, but then the second time you've taken one out, and so you're only picking from 3 marbles. So that's why it's 4 times 3, which gives us just 12. Hopefully that helps you distinguish between these situations, and hopefully you feel more ready for the exit ticket. Good luck, and email me if you have questions. Bye, everyone.